How's
All
it now?
right. Try it again.
How's it now?
Yeah,
Oh, I
better.
can't hear you.
Speak
No,
up.
just kidding.
Whatever you think is loud, do 2x.
Okay. Yeah.
we've been we've been live for a few seconds now. Hi everyone, thanks for joining us today. I'm very excited for another deep random talk. Today I have with me my awesome co-host Serena as well as Dennis and Yuvender. So I'm gonna ask Dennis and Yuvender to quickly introduce themselves, and then we get going.
Hi, everybody. I'm Dennis, machine learning architect at a startup called VoiceFlow. So here I'm leading the machine learning efforts both on the model deployment side of things. Prior to this, I was a senior cloud architect at RBC working on the data systems there. So excited to be here.
Yeah, I'm Yuvender. I'm working at Bensai, which is a biomedical AI startup based in Toronto. I'm working as a data engineer, so leading the efforts in building the data infrastructure for the platform. Previously, I worked at a nuclear company, built a bunch of applications with robotics applications. And before that, I was working as a machine learning researcher at the Vector Institute.
Very cool. What did you think about our session last week about nuclear physics and reinforcement learning? Did you get a chance to look at that? No,
Put
that's
on the
okay.
spot.
testing, testing.
Yeah.
Check it out. It was a good discussion.
Mhm.
I didn't know you worked for a nuclear company, but cool. Serena, what's up with you? What's new?
Well, so I recently changed my LinkedIn tagline because I had appended co-host of Deep Random Walks, and I had the show name wrong for like 4 weeks, I think, until Miriam messaged me and said, "Hey, by the way, your tagline is still off," and I was like, "Oh gosh." So yeah, that's new. That's a big update, big change for the better. Yep.
Yeah, that's significant.
Yeah.
Uh, Awesome. Yeah. So today we are going to talk about an interesting topic. It's more on the engineering side of things compared to what we've been talking about. And this is episode 9. Can you believe that? It's almost 2 months. Uh, so yeah. So essentially, in a lot of ops and engineering settings, you have to deal with situations where the nice looking things that were doing stuff for you in Jupyter Notebook have to deal with real world, and in a lot of cases real world is really fast and it is almost real time, as we see in a lot of applications that we use every day. And that's what we want to talk about today. What does it take to build applications like that? What are some of the nuances of deploying machine learning models that are capable of handling data in real time? And that comes with this paradigm split between batch and streaming that probably a lot of you have heard of. So maybe Serena, you can get us started there. What are these two paradigms, and what are some of the
Yeah.
nuances?
For sure. First, we should do our question of what's everybody drinking? I'm drinking just some
Oh
water out of
yeah,
my
cool.
Starbucks mug. What
I'm
about you
having
guys?
some peppermint tea infused with coffee.
Wow.
I know.
Another dirty drink.
I'm
I
just
just
a
have
water
water too,
person.
Okay,
Yeah.
nice.
in a slightly egotistical mug.
No, it's great.
You-
You gotta promote yourself.
yeah, you're drinking
Exactly.
water like a boss.
It's like drinking your own Kool-Aid.
Yeah. Cool. Great. Yeah, lots of water fans here. Um, Yeah, so batch versus streaming, as Amir said, is what we're going to be talking about today. So I have only ever worked with batch. Streaming is something that really fascinates me, but I don't know much about how to apply it. Um, and when I think about these two paradigms, I think of it from the perspective of inference, and I might be wrong. And my understanding is that in batch, we make model predictions at one time and then store them somewhere, maybe like in Redis, as I had done in the past, and then we pull these predictions from storage at serving time. And then streaming, on the other hand, we do inference continuously on live data. And I think this has implications where the model might have to be less complex in order to be able to like do those quick predictions. And yeah, I'm just thinking, so like, let's say you have a case where you've trained an image classifier on, you've trained an image classifier and you have it stored on like an app on your phone, kind of like maybe hot dog versus not hot dog from Silicon Valley. And then so you show the app a picture of a hot dog and it says it is a hot dog. That inference, I think, is done real time. So would we consider that to be streaming?
I think you can say it partially. It's really hard to define what is streaming, because right now it's still a new like paradigm that is coming in, and there are a lot of opinions from like engineering perspective what exactly is online ML, or like the online or like the streaming, like will it be considered streaming or not? Maybe not, because your model is already pre-trained. It's not that your model is getting augmented in the real time with the data. It's just that you're feeding it the new data and it's spitting out the like the predictions. So probably not strictly in the definition of streaming, and more in the like the paradigm of batch.
Yeah, I think it actually falls into third, based on the use cases of more sort of edge-based deployments, right? So it's a buzzword in the industry, right? But if you have models that are being stored in data, I think it's a different use case. I think streaming, when a lot of people talk about streaming, they also talk about the complexity of data flow, right? So I guess, Serena, to your if you have one picture and you classify it hot dog or not, and you have like a live feed of 1,000 people like trying to figure out if something's a hot dog or not, right? That introduces significant more complexity on the data engineering front, and even on the inference side, right? Because you're now doing data processing processing in real time before making your inference, right? So that's more complex, and it gets into the discussion of, are you doing local work or like local inference or like server based? So for me, stream processing, I would say it's real time. I think we can talk more about what real time means. Trader's definition of real time versus like a CRM app. But then also there's like a significant amount of data flow coming in. I think online training, still think very few companies are doing online training, but we can go through that too.
Yeah.
So is it like batch versus streaming more so refers to the data flow, and online versus offline training, that's sort of like a different thing?
Yeah, I would say so. I think you have control over batch much more so than you have streaming, in terms of how the data is coming in and how you can do some tricks to minimize latency and maybe boost performance, because you're like prepped, right? You're scripted, as opposed to doing a live. It's kind of like, I guess, impromptu versus a scripted show.
Yeah. And to elaborate on that, like so say consider a scenario where a person goes to a website, and then you start a session for that person, and you start logging their activity. Say it's an e-commerce website, they're looking up different stuff, and they're searching 5 different products. You log their activity in the session, and based on that activity, you are generating the embeddings based on that specific session, and you are using the activity plus like the product based embeddings, and then you are creating those new embeddings for that specific customer based on the product based like that you already have, and the activity to generate new recommendations. I think that would be considered somewhat of a new like this online inference that is happening right at that time, and then you're providing them the new suggestions based on their like live activity
It's like
within that session.
you curated that example perfectly for me. That describes some
Yeah.
research I've done. That's really cool. Thank you.
So it's like so if you consider this is encapsulated within that specific session. You're not considering the historic information, their historic activity information. So that's what this whole like online processing entails. That you're doing it within a session.
So I'll use an example in voice flow. So voice flow is a conversational. So basically, for designing chatbots and voice assistants, you can use the UI as well as APIs to sort of construct that flow and I guess cross-functional teams to collaborate. So when you use the tool, it's kind of like a visual programming language. And one of the things we're working on make that process more intuitive and faster, right? So whenever we sort of program or do something else, right, we copy paste, we go to Stack Overflow, right, we do all these things to flow. We could also use the platform that Amir is building, right, to speed up that process as well. But from that perspective, if a user is taking a certain amount of action, recommendations, some of those recommendations could be quite simple using heuristics, right? In terms of, for example, a user hasn't added a part to the conversation that deals with errors, right? That's like fun. But if we want to figure out if a user is stuck on or if a block is not very intuitive, right? That's a lot more complicated. So it even gets into the question of what kind of models are you serving during inference, right? For like streaming data, are you logistic regression or something else, or are you serving like a massive language model? And each of those will impact how you actually serve it, what technologies you use, which is, I think, really important to really define the use case before jumping into that.
Interesting. So I want to summarize what we talked about, because we talked about a lot of things. So it sounds like what I heard so far is that there are 4 categories. They might overlap or not, but we can talk about batch processes, which could be training or inference. There could be online processes. And is that mainly just in the training part, not necessarily in the inference part, or can that be? We do need a bit of disambiguation, I guess. There are 4 different terms that I heard in the conversation: batch, streaming, online, and real time, right? And you talked about data flow as well. So I think there's a relationship between data flow and these 4 terms that we are using, right? So depending on data flow, we are falling into one of these. Can somebody summarize that quickly?
I guess
sure. Yeah, go ahead, Dennis.
I'm going to say that for me, I use real-time streaming, online inference synonyms. Maybe the definitions out there, and people are cursing, confusing the terms. But from my perspective, you're doing inference in real time, right? I think online training is its own can of worms that gets itself, because you can't run a bunch of beefy GPUs in real time. So even your method. So I would say just real-time inference would be sort of the term I would typically use.
Yeah, I think it's the same thing for me. Real-time inference is the term that I would I generally use. I generally switch between online and real-time, but there are formal definitions. And generally, sometimes when people are talking real-time, they're not talking about real-time inference, but real-time analytics, which is just serving the data, right? The data you're coming in is you're just serving it as graphs or like reports. But real-time inference is where this new paradigm shift is happening. So that's kind of the main focus for the like talk that like when we are talking about the online or like real-time systems, it's like real-time inference.
That's awesome. Yeah, I think I have a better idea of the difference between the two. So yeah, like I said, I've worked only on batch before. I guess the context is that when I was working in asset management at my previous role, we really only needed to make predictions of whatever we were forecasting at like particular intervals related to when we were trading. So I guess my question is, why does streaming even matter? Maybe like, are there some examples of streaming that, I don't know, that we are all familiar with but don't realize that it's actually streaming?
Yeah. So to give you an example, say you started e-commerce site and you are giving recommendations to your users who are coming on the site. So you have two type of users. You have new users and you have existing users. For the existing users, they come in, you know that you know their purchase history or you know their activity history, what they'll like to take a look at. And then once the user comes in, you start a session and you uh, go fetch the data from your existing history, and then you provide them with the recommendations. But what happens when a new customer comes in? So the new customer is going to come in, you have no data. So you might have some sort of generic recommendations that you have built for those new customers based on location and like different product types. But generally, a lot of big companies, like I've talked to a few engineers from Tencent and like Amazon. The problem is that those customers come in, they just leave the site because they didn't see anything relevant. So that's where you need that online inference, that as soon as they come in, based on some of the like the product based embeddings that you have stored in, you start building that online profile within that session. And then as they move in, you start providing them recommendations. It sounds in like to me it sounded unintuitive because like you have no data, but then that's kind of like the approach that they are taking to minimize that first cold start problem for these new customers. And similar thing is happening in the logistics industry as well. Say DoorDash. DoorDash has to, once the order is placed, they have to do a lot of online inference based on like the how many drivers are available, which location, what's the weather, all those vectors. They have to do it real time. So that's like a case which is happening real time, like in most of these logistic companies like Uber, DoorDash, these ones.
So in general, cases where the expectation of the customer is to see something relevant right away, rather than waiting for us to build build knowledge about them and then give them recommend. I guess it is mostly in the context of recommendations then that this becomes fairly relevant, or are there other scenarios that this is relevant?
Recommendations is a big one. Advertising. Facebook has a very real-time sort of advertising engine. Like their recommendations are on spot and very timely. So it is very close to real-time inference. And then recommendations in e-commerce, and then the logistics space. Logistics is gonna be big, and it's already big for like this, like groceries and DoorDash, or like food delivery, or just like rideshare. So they need real-time inference.
Yeah, I think, Amir, you summarized it well. Anytime the user is that they're going to receive a recommendation or update or something else within their attention span, right? So you're designing something, as I mentioned earlier, and it takes 5 seconds to get a recommendation, you're just going to close that page or whatever, right? It doesn't fit into your workflow, so it doesn't make sense. I think different workflows have different required, right? So if you're scrolling through Instagram or Facebook, right, and you look at a certain post for a long amount of time, it's in the background what you're interested in at that given moment, right? You might have 20 seconds as a model or a piece of infrastructure to serve the next set, right? Because the user isn't immediately through. Maybe they will. I'm assuming they won't just power 100 posts in the next 20 seconds, right? So as a system based on user behavior, you have the ability to set what your are acceptable to the end user. Internally, those are different just because all the systems are complex, but I think it's just your user expecting to happen. And sometimes it just doesn't feed it all live, right? So a lot of times we fake these things, right? As we fake a lot of machine learning performance, right? You fake the actual recommendations being real time, right? It could just be happening in the background where you're gathering information, and then the user clicks, things already happened, but they just didn't know it, right? So I think that really determines how it works, and there are certain where you can't really fake it, right? So if you're like an assistant, like say Alexa or Google or whatever else, if it takes them to think through, you're gonna lose focus, right? It's like if we stop talking and started pondering about a question for a minute, everybody's gonna the information stop flowing. So this is where the infrastructure, I think, question starts to come up, is that what are your requirements, and also can you afford to go back and forth to like or semi-centralized server to fetch the data? Because sometimes you can't, and sometimes it's too expensive to do that.
I think we spent quite a bit of time, in the first about 20 minutes talking about important properties of data, and the different types of flows that data might have when we are dealing with the streaming use cases and applications. But, as Dennis, you alluded, there are implications about what kind of models can be used. Obviously a model that takes forever to respond, the user is going to be bored and probably 6 websites away already, right? So, but there are also implications on infrastructure and the ways we're doing the delivery. Like if the delivery, as you say, needs a round trip to some remote server every time the user clicks on something, obviously that's not going to be a suitable application. But Serena, I know you worked on session-based recommenders. Is that sort of falling into this category of what we're talking about? Like essentially you were developing a model that can learn very quickly from the user's behavior within one session, and then use that to make recommendations to them. Is that what I remember correctly?
Yeah, you're remembering correctly. And what your vendor was talking about earlier really touches on, like, as he was saying it, I was like flashing back to when I did that research. What we did is we were taking advantage of historical information when it was available, but using something like BERT to treat that sequence of clicks as the information that from which we would then learn like a user's affinity for certain products. So yeah, like very much related. And yeah, I mean, like what I just remember is when we were making the arguments in our paper for like why this was novel, it was because it was one of the first times that we were applying like sort of streaming capabilities to the recommender systems problem.
Very interesting. So what are some of the other model level consideration that we have to think about when we're designing systems like this?
Sure, I can speak to that. So what we have discussed so far is like the streaming infrastructure layer. So the next thing is like the ML engine, right? The ML engine has to be fast enough to do recommendations in a small time, or inference in small time. So for the ML engines, there are a few things that like you have to consider when we are going in this real-time online paradigm. Is the feature stores, the features that we are providing the models, and the models themselves. So generally, like these days, we are using feature stores to store the historical features and manage the features, do the versioning of the features. But currently, what the feature stores are lacking is they don't store the code to generate the features based on the new data. So that's something that at a model level that we need. There's like new scope for this kind of tech to be included in the feature stores, where you have new data coming in and you are generating features based on some pre-stored code based on the previous features that you have in your feature store, and your feature store is capable of generating those new features. Now, once you have those new features, the next step is that you pass those features into a model and augment your existing model, or you create a brand new model. And for that, generally, what like in the production systems, model stores are used. And model stores, what they have is they have a queue of different models based on different use cases, or like based on different kind of data. You can assign that queue of models for like the kind of data that is coming in. But when the new features are coming in, your model is getting augmented. And where do you rank that model in your model system? That do you want this new model with this new feature? Is it actually good? So what we need is a model evaluation system as well. And it should be fast enough that the request, when the user sent a request, the data new features are generated, new model is created, and then the evaluation of that new model, and if you want it to be used as your top model or versus the previous model, so you are able to do that comparison in a very short time. So that's the kind of new scope in this whole like new scope for new products is coming in. So if we can build a model store which can do evaluations for these small models at a really fast time, that's where we will see this like infrastructure, like the ML based infrastructure coming in.
You mentioned like we want to be able to evaluate model perturbations or updates based on new data or new calculated features coming in. I get that. I get why you would need a new evaluation system, but is the reason we need to do the evaluation is because we've used the latest data because of that streaming piece? Like if we didn't incorporate any of the new data or calculate new features, then that would just reduce to batch?
That would, yeah, essentially then you're not using any new data, session based data, right? And then you're not doing any new you're not generating any new model for that, like the latest data to accommodate, like to augment your recommendations. So you're essentially, yeah, you're then just going back to your previous like already set up infrastructure that you have in place. But this is something like when we want for those session based, we might have, depending on the use case, it might not even be in every use case you are generating a new model or anything, but it's gonna be the case for a few of the use cases where you need a new model, evaluate it fast, and reduce the deploy time. And that's where we're gonna see some new products coming into the market.
Yeah,
Right.
I think it's interesting because I guess even within the space of, say, model deployment, comes in with a different perspective of what real time is and the tools, right? So if you talk to, say, a data engineer, right, when you, I think Kafka, right? When you talk to, say, an engineer dealing with video data, right? Well, they're using a different set of tools. If you're talking to somebody, the high frequency trading tools, you're talking to somebody in the conversational space, right? Different set of tools. So I think that's where you just need to define those requirements, right? Because otherwise, if I say streaming and you say streaming, we might just miss each other. And with the actual like model deployments there, I think technologies out like in the past 2 to 5 years, it's just explosion, right? So there's a lot of interesting work being done at large companies, right? So there's a resource we'll share journey of going through doing batch recommendations to streaming recommendations. Oh, there it is. Didn't know we can screen share. That's pretty interesting to see how a large company has done it in the past 7 years based on a business problem that's been happening. Obviously, most people don't have the resources of Netflix to go ahead and and build these kind of internal systems, but we interesting things, right? There's another resource in here based on Hugging Face's sort of deployment strategy and how they deployed sort of 1 millisecond model inference with their own technology versus some open source ones, including Triton and a couple other ones. Yeah, lot of interesting work being done. I think as the ecosystem matures, to have more tools available to us as people working in startups are tackling new use cases. I think that's where you just need to define what you need to solve, because other times there's other interesting things. Like there's startups working on building real-time Redis inference, right? Where you could actually do your Redis itself. So not just using it as a caching layer, but right? So we get into some really interesting use cases there. But for now, I think since I'm working in the processing space, just how do you speed up transformers, right, is one question. The other question is how can you actually get rid of transformers so you don't have to spend as much money running GPUs or large CPU. How do you make smaller models? How do you get into user personalization? I think we've talked a little bit about that, but you can't deploy 1 million BERT models, right? Well, you can, but you probably shouldn't. So it's an interesting space for sure. To quickly things evolve in 6 months to a year with technology.
For sure. Just very quickly for our audience, what I'm sharing on a screen is a recipe that you can click on in the show notes if you're watching now or later. You can take a look at all these resources as well as our notes about all of them. On the topic of feature engineering, for example, I found this article on DoorDash's blog that I think reflects a lot of the things that your vendor was talking about, and definitely highly recommended to take a look at it. There are also a lot of other resources that you can use. But one interesting thing that you can do is, if you come across anything that is relevant to this topic and you want to let us know, you can go to these related resources section and then user recommendations and add any recommendations that you have in terms of resources that are interesting and relevant to this topic. And we will make sure to check them out and add it to the recipe so that other people can use them. So I wanted to, maybe since I'm sharing my screen already, I wanted to ask each of you who done research for this session, in addition to the experience that you already had, so essentially, if the audience who's watching this wants to only look at one resource, I think we have, like 15 resources here and probably even more later. Each of you maybe can say, what's the one resource that people should definitely look at out of the things we are showing here? Maybe we can go. Yeah, your vendor, you were about to say something. Go for it.
Sure. Yeah, I would recommend the one article that is there, machine learning is going real time.
All right.
Yeah. This one is, it talks about the overall like abstract concepts around what needs to be done at an abstract level for the companies to go from batch to this online system. And it talks about where different stages of this transition will look like. So it breaks down what the transition will look like for the companies which are already doing like batch and want to go towards streaming. So it gives you a very good understanding of the overall concepts and like the underlying problems that needs to be solved.
Okay.
Yeah, so for me, I didn't actually add any resources this time because Dennis and your vendor just did such an awesome job. I'm definitely going to go read that Netflix article because I know Netflix usually puts out very good technical blogs, and I'm curious to see how they went from batch to streaming.
From my end, I like the Hugging Face article a lot. Usually when people see or something else, they run away. I think there's a lot of really good material in there. I really like how they walk through the steps of like optimizations. It's the thought process, I think, that you're going through, right? It's working, start thinking about how you can do reduction in precision and a couple other tricks for it. How can you actually optimize your model? Do you distill it or do something else too? How do you export it into a faster runnable format, right? If it's TensorRT or whatever else, and then at the serving layer as well. So the one thing I like to note is that resources with code snippets are amazing, but I resources with benchmarks, right? So benchmarks are awesome, especially for latencies. You actually have to dig through because a lot of the technology vendors are like, you can expect like order of magnitude 10 millisecond latency. And you're like, okay, does that mean in the like 95th percentile? Are we waiting for a second or 10? So those questions are always great to be answered when people run their own benchmarks. So benchmarks are great when talking about real time because again, 10 milliseconds is real time for somebody else. 100 milliseconds is real time for a different person.
Definitely. So speaking of benchmarks and performance, obviously when you have a lot of resources, performance is less of an issue. Obviously, it still impacts the customer experience, but when we talk about edge devices, like if there is data that is coming from sensors or your phone, or Mark is asking in the chat about ASIC processes or devices, or any other types of applications, for example in agri-tech where it is very sensor heavy, in aircrafts, when they're constantly collecting a lot of data on the air. So, and another person in the chat, sorry, I forgot the name, I quickly look. Swagat is also asking about good resources about MLOps on the edge. So let's shift focus to essentially everything we talked about, but now you don't have resources to run this. Like you don't have a GPU on your laptop, sorry, on your phone or a sensor or some other edge device that you have.
And I'm also wondering, when we talk about lack of resources, so there's a lack of hardware resources, we can definitely like use the cloud to get access to these resources. But like when we say low resources in terms of the money, how low do we mean?
Right.
Yeah,
I think it's a great question. I think, Amir, in a lot of use cases, you get transported like 10, 15 the capacity, right, of like embedded systems and some of those chips that are being manufactured, right? You're getting back down megabytes worth of RAM, right? Processors are much slower. Like forget about having like GPU enabled or GPU specific hardware, right? Or a couple companies have been touting recently, right? So definitely yesterday or 2 days ago when NVIDIA announced the H100 is just massive, but you can't, like, it uses 700 watts. So definitely different paradigm. I think from my perspective, I haven't done embedded work. I haven't done sort of low resource machine learning. I've worked with neural networks, and I've cheated times by just deploying a GPU to get the inference time down. So I think it really depends on the model. What makes cloud really great is that it's often there's a pretty nice free tier, right? So if you're using Lambda, for example, if you're deploying like really simple models and serverless, like that can be very cheap to start. Google PubSub for our streaming, and that has quite a few million sort of free messages that can be. I think definitely take advantage of those cloud. They try to get you hooked, right? And then all of a sudden your usage 10x's or 100x's, and it's much more expensive. But I think take advantage of that. If your use case fits a use case that a startup company is offering for something, I can talk a little bit later about how we basically built our own inference and modeling system. But engineering time is much more expensive than other time. Like you can leave an A100 running on GCP just aimlessly, and it'll cost you way less than engineer, right? So don't forget that too.
Yeah. Another resource I would say is that like Amazon, AWS, and Azure has their own specific IoT-based like cloud solutions. So definitely worth looking into those, because those are already way more optimized than you can like do at your startup. And then, as like Dennis said, that the engineering time is way more expensive. So look for those solutions. They have reliability and they can give you a really good baseline. But yeah, for the bigger companies which already have like a lot of resources and a lot of money, they can do their own experimentation. It's feasible for them, but it's really important to evaluate your desire to solve a specific problem versus like the feasibility and the like a practical way to solve that problem. So going for cloud solutions is definitely a good go to like for these low resources problems as well.
So if I had like $10,000 and I wanted to do like online streaming, learning stuff, would I have enough money?
It depends on how well you can provision your resources
Okay,
on
I'd probably
cloud.
blow it all pretty quickly then.
But yeah, no, cloud can definitely save you way more time in terms of the engineering effort versus the actual cost of cloud is going to be still cheaper than probably what you have, because you're going to be investing in hardware anyways if you go with that other route.
So one thing that you said that was interesting for me is that there are specific cloud infrastructures for IoT purposes. So what's special about them?
Specifically, I haven't worked with them. Like I have done a little bit of research into Azure's like IoT device setup. So they generally like the one thing that I found as a new user to that specific service was that it gives you a very like thinking philosophy of how do you approach these problems. So say as a ML engineer, like my experience has also been mostly in NLP space. So you have to think about a certain like philosophy when you go into any new like uh, way of doing things. Like for IoT, the way you code, the way you write software is has a very certain philosophy to it, because the embedded system philosophy. So so those frameworks all the way those are designed, the way you're going to be deploying your services, just by looking at those like how those services interact with each other, you can learn a lot about the philosophy. So that's like one thing that like kind of caught my eye when I was checking those out. But personally, I haven't done any in-depth work to like give you like a very detailed
That's cool.
overview.
So if I summarize what you said, what I took away from that is that there is a lot of system design thinking that goes into using your resources efficiently and setting things up properly, and essentially these probably IoT specific cloud infrastructures abstract that away and essentially give you standards that you just go with, and you're most probably fine. And Mark Donaldson, I'm sure, I know Mark is working on some sensor based applications, and we should actually bring him to this show at some point to talk about that specifically. Um, and he's mentioning in the chat that AWS IoT Cloud and AWS IoT Greengrass are some services that provide applications like that. But Dennis, you said you hacked this together in house. How does that work?
Yeah, so it's a decision that we'll see if how good of a decision it'll be in the future. But basically, we built our own streaming machine learning platform, both on the MLOps side of things and on the modeling side of things. So we wanted to make it quite generic in terms of what we want to deploy, right? So we Dockerized everything, we scripted a lot of things, templated a lot of things for models where we would save a lot of configuration of creating a model, right? So if we've all tried to deploy a model, there's you on no, Docker is not serving this properly, right? You create your serving infrastructure, suddenly your models aren't loading properly. So we just templated all of that out. But in order for it to be generic enough, we needed to have interfaces. So on the sort of data flow side, we just send messages in and out from a model, right? Streaming data in through PubSub, and what's really nice is that it actually has schema validation in it, right? So one of the things that'll is that if there's malformed data, but because the service it's schema registry, it'll just reject messages from the other side. So you know that the data coming into your model is going to fit that. So there's a couple of things we've built in just process. That was one of the things as well, is how do we make it even faster for a data scientist or ML engineer to build these models? Abstract away sort of, Amir, what you talked about, that system design. Not that people have to stop thinking about it, but they don't have to worry about the nitty gritty details when they're trying to do something else. So that was kind of that. You also, as a smaller company, flexibility as you're doing sort of product discovery, right? For example, if I was to deploy Triton right away, kind of be locked. We should know what kind of problem we're solving right away. As a startup, the models you're building, right, they're changing quite quickly. So we made it as generic as possible. Once we figure out that these are like the 5 or 10 or whatever models that generate us a lot of customer value, right, then we can start optimizing. So we sort of rebuilt everything to make it as generic as possible and machine learning and data scientist experience. And now we're starting to reap the benefits where you want a new model, here's 3 deployed. But yeah.
Dennis, how long did it take you?
Investment.
How long did it take you to build that if this isn't proprietary information?
The building. But
I guess to get the first MVP.
I think it took 2 months to get it working. And we've added a lot more improvements recently. I've actually been of every month what we've added to the platform with some demo videos. But one of our team members added like logging and monitoring into it. So we now have the ability to do A/B tests and sort of keep models in like a shadow mode so traffic doesn't go there. So that's been quite good. And it's been a open source and sort of cloud native tools. We basically just went out and did some research and said, okay, this is going to make this works for us. Oh no, this doesn't work. Swap it out. For example, GCP released a new feature which was called image streaming, which lets you load in large models, take large container images and just like start them up really quickly. So rather to deploy a large language model that's containerized, it took like 1.5 seconds, right? So we kind of benefited from that innovation. It was an interesting process. We're around 8 months in now, and yeah, features are getting added all the time. So.
That's awesome. That's really interesting to hear the build versus buy discussion. I feel like I have so many more questions to ask you, but it might get into the territory of proprietary information, so I'll hold off. Another discussion that I was hoping we could talk about is, well, I guess like everything we're talking about right now feels like it's been very North America specific. We've mentioned Netflix, we've mentioned DoorDash, Hugging Face. When I was doing recommender systems research, and I don't know if this is specific to Rexus or not, but a lot of really great state-of-the-art work was coming out of China. And I know you said that at the beginning you were chatting with some folks from Tencent. Does anybody have insight into like what this streaming paradigm shift looks like over in Asia?
Yeah, a few things I can comment on based on my conversations. Those aren't very in depth, but like the the way engineers put it is that especially the people who have worked in North America and China is that the focus, like the day they joined Tencent or Alibaba, the focus was mostly on the like real time, uh, close to like the real-time systems versus in North America, where like most of the companies they worked were like during the time of like between 2018 to 2021, that like most of the companies are doing just batch work. And companies like Tencent, they have a lot of like gaming applications where they do a lot of real-time inference on like what the gamer's activity is, and then do like dynamic product recommendations to them for their in-game sessions, so like they can buy stuff and then do like actions based on like their needs, their play styles. So the engineering capability they already have way more mature in like these companies compared to some of the big North American companies they worked at. And secondly, there's a lot more enthusiasm compared to like the North American companies to push towards this real-time system. So it's not quantitative to say like how better they are, but like it's general like anecdotes that I've heard.
Now, I wonder why there is more enthusiasm over in Asia compared to here. At least speaking for Canada, maybe this is getting political, but I feel that we're generally quite risk averse in Canada, and I think that sometimes translates into how we innovate, whereas in the States, it feels like Americans are risk taking and more innovation focused. Over in Asia, I think part of it is, and this is speaking from my time doing my master's in Asia, working with a lot of people from China. There's a lot of pride in how innovation is done over there, and I think just like a huge emphasis. So it's like if real time is the next thing, like we're going to focus on real time.
I think it's part because they have larger populations. They have more data coming in, and those problems hit those companies before these problems are hitting like North American companies. Because yeah, North American companies are super successful and all, but like probably the sheer amount of like people who are using the applications in like China, right? Like Tencent has a lot of applications. Their user base is like could be like their active user base could be like way bigger, so they had to approach these problems real time, probably years before the North American company. So that could be one reason as well, not just like the risk taking, because a lot of the times probably like making your system 10 seconds faster might not be that worth it to the business OKRs. So you have to consider it from that perspective as well, that like online systems are not just a technical achievement, but like those are also deriving the revenue and like the business OKRs as well. So there are trade-offs.
Yeah. I mean, on that point, we sort of talked a little about, the relevance of streaming applications and online applications is mostly, not mostly, but an important component of it is the user experience, right? Like if we don't deliver relevant insight just in time, the user is just going to walk away. And I think we are at a point in the history of technology that people have options. They don't have to stay on our application. If I'm using a vegan recipe converter and it doesn't give me relevant results right away, I'm just going to walk away and use the next one, right?
Yeah.
That was plugged for Serena's application, by the way. Or if I'm using this voice flow kind of application that allows me to architect things with low code, and if it doesn't have the right recommendations, I walk away. And same with um, antigen information that I need for my pharma company, right? So And I think part of the interest there is that if you don't capture the attention of the user, they're going to walk away. And now the question is, how aggressive are you as a product owner, as a product company, to really want to capture their attention right away and don't let them go away? And of course, as you said, that sort of product aspect, I think is very, very significant as well. Unfortunately, we are running out of time, and this is a fun conversation. I don't want it to end, but the last bit, essentially, what's your verdict? What do you want people to take away from this conversation? A call to action, or just summarize your thoughts very quickly.
And if there are any open questions, please note
Right.
those, as someone in the chat, Yazan, was asking.
Oh yeah.
Yep. A few things that I would say is like a few industry trends we're gonna see is like building that fast infrastructure layer where the user response, like user comes in, does an activity, and it goes to your prediction engine. We're gonna see significant improvements in that field. In the MLOps field, we like the future that I'm seeing is that the feature stores will be able to store like the codes, and like their capabilities will be to generate the new features as opposed to just like storing the existing features. And then we're gonna have new products around like model stores and but all these products will have to consider like if you're a new startup and you are thinking of like breaking into this market, you have to think of your competition is going to be with in-house, because big companies like to do work in-house. So probably if you want to build a sustainable business around these like new tools, you should consider thinking of accommodating like how can you become like an in-house tool rather than just like a enterprise tool which is giving like very limited access to the users. Because when a company is going to grow, they're going to go in-house, and that's going to be your big competition. And like VoiceFlow, like Dennis said, they built an in-house solution recently. DoorDash centralized all their machine learning platform, and they went in-house with like open source tools because of a lot of the problems the tools they were using weren't solving that. So I would say just like if you are trying to break into this field, think about that.
I would say that real-time systems are hard. Be really sure you want to build one first. Get your requirements in order before you go onto the journey, because there's simpler ways to do it. There's a bunch of there. The cloud ecosystems are evolving. Lots of really good stuff out there. So you can build a real-time system and not it won't be too big of a distraction now. Sort of a keep your eyes out for cool stuff, but don't forget all the other important things of cloud infrastructure, MLOps, data quality, etc., because that'll really hurt you more than choosing the wrong streaming tool.
Yeah. Trade-offs.
Serena?
Yeah, I'm just thinking on my end, I'm excited to see how the field evolves. I'm always curious to see how innovation in North America keeps up with innovation in Asia. So yeah, I wonder like at what point are we going to have like a real motivation to use real time rather than batch, similar to China. Who knows? Maybe a few years, maybe longer.
Yeah, we should actually do a session on that. On
cool.
that note, we are almost out of time. Yazan has a good question, which is, what else should we have talked about? I think one topic that we didn't talk about, but we have quite a few resources about it on the recipe, is essentially open source tools, like actual tools that one can use to create systems like that. I know we have quite a few things on Kafka. What is the other thing called? Flint?
Yeah,
there you go. But I'm sure there are many other tools like that. So I think that would have been a good question to talk about, but unfortunately we are out of time. Lots of interesting topics, both on the engineering side and on the product side. I think I didn't expect us to get much into the product side, but that always comes up. Thank you so much for watching this. Make sure you check out the recipe with all the resources and notes that we have found when we're researching for this session, and suggest resources if you find anything useful. We will definitely add a few more things based on the questions you asked and what we talked about. But thank you so much. Join us next week. We have a very exciting session coming up. Thank you.
Bye.